Mr. Trufan, and in this video, I'm going to demonstrate a Beer's Law experiment. We already completed a serial dilution, and now we are going to connect the concentrations of those solutions to their respective absorbances. And then we're going to see whether it is true that there is a linear dependence of absorbance with concentration. So let's get started. For today's experiment, we're going to need a vernier spectrophotometer, and that is here. This is a wireless device, so it will need to connect to some kind of display. And for today, I will be using my iPad. Next, we're going to need our solutions. Here I have my original stock solution that I already poured into a cuvette. It is important that we collect the first measurement on this sample so that we know which wavelength to monitor to establish the linear dependence. Next, we're going to bring in all our differently diluted solutions. And in this case, I labeled them with the respective dilutions compared to my stock solution. Then I will need 4 different cuvettes for my 4 diluted solutions. And just like before, with these plastic cuvettes, I am only going to touch the ridged sides. I will fill each of these cuvettes approximately 3/4 of the way full with solution. Place a cap on top, and then create a careful association between my stock solution and the cuvette without labeling it, because the cuvette will need to go into the spectrophotometer and any label will interfere with that. If there is water or solution on the sides of the cuvettes, it is important that we wipe it thoroughly with Kim wipes before we insert the cuvettes into the spectrophotometer. So now that we are ready, let's set up. The first thing that we're going to do is go to our device, click Untitled, New Experiment. And again, if it is important that you save your data, you need to save it. Otherwise, click Don't Save and you are ready to move on. Next, under Absorbance, you will tap the down arrow, and then there are 3 options, and of those 3 options, you will select versus concentrations, in parentheses, Beer's Law. It will take a second to get started, and this is where you can do the following to make your task easier. Place your cuvette inside the spectrophotometer, and as you do that, it will show you the full spectrum of your sample. And then, just like that, if you forgot the wavelength that you originally determined as the wavelength associated with the highest absorbance, you can once again select it. In this case, it will be 501 nanometers. When you selected it, click Done. And now, as you enter your new experiment, you will type in 501 nanometers, and you're ready to collect. There are a couple things you need to know about this. First, in order to keep your data that will not show up until you type in your concentration, you need to press Keep. And under Keep, it will prompt you to enter the concentration. Because we don't know the original concentration, if we haven't calculated it already, it is best to go with an unknown. In this case, we're simply going to type in 1. And when we say keep point, it will place it on the graph. Now we are ready to extract our first cuvette. We add the second one in. It will record an absorbance value, and it is always best to wait a couple seconds. Once the absorbance value settled on a number, then you press Keep, it will prompt you for a new concentration. And for this one, we have 0.702 if we assumed that our stock solution was 1. And then we press keep point. Now we can extract our cuvette and place in the next one. Again, we wait a couple seconds for the absorbance value to settle. Once the fluctuation stops, we press keep, and we type in the concentration compared to the stock, 0.503. And tap keep point. We're ready to move on to the next one. Our absorbance value settled. We tap keep and type in our next concentration, which is 0.350. And then press keep point, and we move on to the last measurement. Now we tap keep point, and we enter our final concentration, which is 0.247. We are done with our measurements because we collected the absorbance value associated with all 5 of our solutions. So now it is time for data processing. That is really straightforward. First, we go to the bottom of our screen, the bottom left, and the first thing that we do is make our graph look a little bit prettier by saying edit graph options. It is best to give it a title, and this is our red 40 dye at 501 nanometers. We can set our axes, and we can always go from 0 to 1 on the concentration. It is best to go to a little bit higher than the largest number that we have. And for our y-axis, we can set it from 0 to 1. And with that, if we tap out of it, we see that our graph has been adjusted. Now we once again tap the bottom left symbol. We go to apply curve fit. And because we expect a linear dependence between concentration and absorbance, we're going to select the linear fit. And then when we press apply, it will give us the information. It will both give us the line that connects as many as the points as possible. And it will also provide us with the equation that describes our line. And from there, we will be able to derive the molar absorptivity value as long as we know the exact concentration of our solution.